You're driving home. It's a road you've taken 1,000 times. You feel safe. Why wouldn't you? You're surrounded by high-strength steel, crumple zones, and that small, reassuring plastic cover on your steering wheel that says SRS, Supplemental Restraint System, your ultimate safety net. But here's the terrifying reality. In a massive number of real-world high-speed crashes, that bag never moves. In the US alone, we are hitting over 6 million accidents a year. That's 39,000 lives lost. And while we're told technology is making us invincible, data from 2024 and 2025 reveals a chilling trend. Thousands of these fatalities happen not because the car was too crushed, but because the airbags stayed silent at the one moment they were needed most. From the high-speed interstates of America to the precision-engineered streets of Japan, where 540,000 accidents still occur annually, drivers are finding out too late that their safety isn't guaranteed. It's calculated. Today, we're going inside the brain of your vehicle to see the exact sensor logic that decides your fate. We're exploring the dead zones where sensors go blind, the hidden engineering war between American and Japanese brands, and the one everyday mistake you're making that might have already disabled your entire system without you knowing it. We need to destroy a dangerous myth right now. You've seen the commercials? Airbags look like soft, fluffy clouds that catch you. That is a lie. An airbag is not a pillow. It is a controlled, pyrotechnic explosion. Inside your steering wheel is a solid propellant, usually sodium azide. When your car's computer gives the order, this chemical ignites instantly, transforming into nitrogen gas. It doesn't inflate. It detonates. The bag moves at over 200 miles per hour. It fully deploys in 30 milliseconds. To put that in perspective, it takes you 100 milliseconds just to blink your eyes. By the time your brain even realizes you've hit something, the airbag has already exploded, caught your head, and begun to deflate. Because this event is so violent, the car's brain, the ACU, Airbag Control Unit, has a terrifying responsibility. If it fires too early, it can break your neck. If it fires when you aren't wearing a seatbelt, it can kill you. So, the ACU isn't just looking for a hit, it's looking for a mathematical signature. It is analyzing g-forces, deceleration rates, and impact angles thousands of times per second, asking one question: is this crash worth the risk of an explosion? Imagine you hit a concrete wall at 15 miles per hour. Your bumper is destroyed. The car looks like a total loss. You walk away, but you're angry. Why didn't the airbags go off? Technically, your car just saved you from its own safety system. Engineers set a deployment threshold. If the deceleration isn't sharp enough, the computer decides the seatbelt and crumple zone can handle the energy. It saves the explosive, because an airbag hit at low speed causes more injury than the crash itself. But this creates a gray zone. The soft impact. Imagine hitting a row of plastic barrels or a large animal. The car sustains massive visual damage. But because these objects give and absorb energy, the G-force spike isn't sharp. The ACU sees a slow stop. It stays silent. The glancing blow. You sideswipe a truck. The metal is peeled back like a tin can. But because the car kept moving forward and didn't stop abruptly, the deceleration signature never hit the threshold. This is the psychological horror of modern driving. You can be in a terrifying metal-shrieking accident, and your car's computer will sit there and calmly decide, "You're fine, I'm staying in the dash." This is the part they don't show you in the brochures. Sensors are not everywhere. They are placed in strategic hard points: the frame rails, the B-pillars, the radiator support. If an impact happens between these points, you enter a sensor dead zone. 1. The underride nightmare. You're on the highway. A semi-truck slams its brakes. You slide underneath the trailer. Because the trailer is high, it bypasses your bumper and hits your windshield and roof. Your frame rails, where the sensors live, barely feel a vibration. The cabin is crushed, but the computer thinks you're just driving over a pothole. 2. The pole impact. Hit a tree or a telephone pole directly in the center of your hood? In some models, the force is so concentrated in one narrow spot that it misses the main crash sensors on the left and right. The car literally folds around the pole, but the sensors never get the signal to fire. 3. The offset crash. Only 25% of your front bumper hits an object. The car spins wildly. Because the energy is dispersed through rotation rather than a straight-on stop, the ACU gets incomplete data. It hesitates. And in a crash, hesitation is lethal. Did you know that your survival might depend on where your car was designed? The American philosophy. For decades, American manufacturers like Ford and GM had to account for a specific problem. Americans don't always wear seatbelts. Because of this, American airbags are often high output. They fire faster and more aggressively to catch an unbelted occupant before they hit the glass. They prioritize protection over prevention of injury. The Japanese philosophy. Brands like Toyota and Honda operate on a different logic. They assume the driver is disciplined and belted. Their systems are conservative. They want the car's structural cage to do 90% of the work. They only fire the airbag as the absolute final 10% of protection. The result? In a borderline medium crash, an American car will almost certainly blow the bags. A Japanese car might hold them back. One saves you from the steering wheel, the other saves you from a chemical burn. Which one do you trust more? This is the most silent danger of all. Most modern cars have an OCS, Occupant Classification System. Under your passenger seat cushion is a pressure-sensitive mat or a weight sensor. It is constantly judging who is sitting there. Is it an adult? Enable airbag. Is it a child or a car seat? Disable airbag to prevent injury. Is it an empty seat? Disable to save money on repairs. Here is how you accidentally kill that system. If you use a thick aftermarket seat cover, you can spread the weight, making the sensor think an adult is actually a child. If you keep a heavy backpack or a laptop on the seat, the system can get confused and fault out. If you spill a drink and it seeps into the sensor, it can short circuit. Next time you have a passenger, look at the center console. If that pass airbag off light is glowing, your passenger is sitting in a death trap. Finally, let's talk about the check engine light of the safety world, the SRS warning. Most people see that little red man with a circle in front of him and think, I'll get to that next oil change. Do not wait. In the vast majority of modern vehicles, the airbag system is all or nothing. If the computer detects a single fault, a loose wire in the seatbelt tensioner, a corroded sensor in the bumper, or a clock spring failure in the steering wheel, it doesn't just lose that one airbag. It often shuts down the entire system. It puts the car in fail-safe mode. It would rather provide 0 airbags than risk a malfunction deployment while you're driving 70 miles per hour. The conclusion: your car is not a hero. It is a machine running an algorithm. It doesn't care about your fear. It only cares about the G-force curve. If you want to survive the no-deploy zone, never ignore the SRS light. It's not a suggestion. It's a shutdown notice. Sit properly. The sensors assume you are upright and centered. If you're leaning or have your feet on the dash, the airbag becomes a weapon, not a shield. Understand the limits. No car can save you from physics if the sensors are bypassed. Because in that final, silent millisecond before impact, the only thing between you and the end isn't just a bag of gas. It's the logic of a computer that has already decided your fate. If you like this video, so subscribe the channel for informative videos. Thanks for watching.